Hello there, this is Al, and this is, or should be, lesson 67 in this series, where I've been trying, over and over again, to try to help you make sense of some of these meaningless, pretty much, meaningless words. Now the first thing is I changed this from standard call to, well, you can see in the bubble here, this is just another way of saying standard call, see, to this. And now I don't know if it's appropriate for me to put that there, but that's what people usually do. Of more interest are these words, which I've classified here as the first one being obscure. That is, why is this called H instance instead of address of my program? And what's this second H instance all about? Now that turns out to be totally meaningless, and the reason it's totally meaningless is a historical one. Command line we understand, and this thing is occasionally meaningful. Now, I just want to try to quickly explain the previous meaning, let's say, of this second parameter, which no longer has meaning. It's always null in our world. In the old days, Windows was still in its infancy, and there was such a thing as 16-bit Windows. And even beyond that, this second parameter was used. In fact, pretty much every Windows program back then began with the following code. If not H create instance like that, and inside here would be a bunch of code, and the last line was always this. Nobody ever checked the return value, but there is a return value. Register class, and then the address of something called a wind class structure. Now, this part is still used, but there's the if not part obviously is irrelevant because this thing is always null, so you can get rid of this now. So what's left is all that funny code that you don't know about, followed by this register class bit. And this register class bit returns something called an atom, and in accordance with the meaning of the English meaning of the word atom, this represents some kind of very basic, fundamental type or object in the operating system called an atom. I'm not going to go into too much detail, except to say that this is a 16-bit value, or was a 16-bit value, and still is a 16-bit value. And there's a limited number, therefore, of these things in the world. In our programming world. Now, going back to the past, what this register class thing is doing is going on the assumption that we're going to create something called a window, which has not been explained. Each window has an associated class. Now, if your program has already been started, right, that is, if there's another instance of your program out there, then it would have already added to a table containing atoms, or these atoms, this structure, well, maybe not the structure itself, but at least an entry in a table of these atom things, whatever an atom might be. So therefore, if your program was already running, you didn't need to do this bit again. Okay. Now, what is, at the most basic level, what's an atom? An atom is essentially a number with an associated string. Okay, like a name and a number. And I don't know how to get there quickly. The atom functions. Let's look at this maybe. Okay, this helps. Now, if you just wanted to add one of these atom things, global atom, to the system, you need to supply it with a string, and it returns you a number. Okay, the string has a maximum length, 255 bytes, and there are some other restrictions. Now, you can also use a number. Just like with our resources, a number or a string might be provided. You can put in the place of this string a number and use a particular type of macro that converts that number into a string, and then the string and in fact the number look almost the same. In fact, that's what I want to show you next. Okay, so the first thing is that this is no longer relevant. It's here for historical reasons. You can completely ignore it. There's no instance involved. There's no second instance involved in the Win32 land, because every application runs in its own memory space and has its own copy of the operating system all to itself, and has its own atom table and so on and so forth. So there's never a previous instance in our address space of our program. That's impossible. If you tried to start a second instance, it too would get its own address space. Okay. Yes. Now, Windows, the operating system, is what I want to talk about generally. Disregarding all this stuff about atoms, and Windows itself, the operating system, is a message-based system. And what the messages are and where the messages go and how they get received and sent has to do with the code that follows here, partly anyway. It's just sort of semi-assumed here that you're going to create a window of the specified class, and then do the following. I don't remember the exact syntax, but it's something like while get message with some parameters, and then there's something called dispatch message. And again, something to do with those parameters, and maybe that might be like pretty much the outlook, the outline of the rest of your program at a certain point. I wonder if I can get an example of a message loop. It's called a message loop. Message maps, message. It's a standard code. It's a standard, like 3 lines of code that every every process enters. Oh, come on. Google. Message loop. I just want to show you the 3 lines, whatever they are. Here it is. While get message, oh, translate, then dispatch. Okay, so I was just saying one line. Okay, now that at that point, that's where the application is doing all of this work. This somehow retrieves messages from the operating system. This somehow tells the operating system to translate the message for your use, and dispatch then sends the message to your window. Now we can see the windows sort of in action with this spyxx program that you have. If you installed MSDev, then it's in this tools directory, and if you run it, it shows you taking the desktop window. Okay, now see here, that's one of those atom numbers. Okay, whenever you see number sign followed by a number, that's a atom identifier. So here are all the windows that it can see. A lot of them look the same, unfortunately. God knows what that is. Oh, that's this. Some various things. Now, let me just take an actual window that we can locate, like Notepad here. And there's a thing in this thing. Actually, I can hide it. I need to have a few things visible at once. How about this? Now this takes up the whole screen. This, and this, and this. Okay. Now, you can hide that bit, and now you can drag this thing around, and it highlights various things that are windows, and is displaying in here something about that particular window. Each one has a handle, right? Each one has a caption, and each one, of course, has a class. Now it's that class bit that is that was the part that could, creating the class that was being skipped in certain instances in the old version of Windows. Now these aren't windows. Let me make a dialog box. Okay, here's a dialog box. I gotta refresh this. I'd like to find that one in particular. Okay. As you can see, this window has a bunch of sub-windows, right? And the last thing here is what's called the window class, right? And the text here is called the caption. Now, each window has a caption. Window's caption. Each window has a handle. Each window has a procedure. Now that's the messaging business. That's how the messaging gets handled. The style bit has to do with creation of the class. There might be a next window. It's all a big happy family. Next and previous, children or no, so on and so forth. What about the messages? That's what I wanted to get to. Let's suppose I go to this, which is this window here. Here, I'll show you. I'm selecting it. I say OK, and that's where it takes me to. But if I select this one, that's this window. So buttons are in themselves windows. We can look at the messages this way. The one I selected was the button that currently says Go To as its caption. And nothing's happening, but watch when I move the mouse over it. See? It's getting messages. It appears to be getting messages even after I move this away, but I think some of it has to do with it takes time to print it out. Holding it down obviously has some relevance. And other windows in here are not being, their messages are not being displayed. It's I didn't select them. If I select the entire dialog, I get messages for everything. Now, I'm not exactly sure why. Because, yeah, actually these are different. You see, when I F8 is stop. If I just select the Go To button, the messages for that. Okay, you see there's a lot of set cursor there. I can scroll up and have a look here. A lot of set cursor, this thing, whatever it is, and mouse move. But if I select just the dialog, I think some of those are not in. Some of those get filtered out. Now I'm just going over here. Right? Now that's definitely not the same. Maybe it is the same. No, definitely not. You see, these messages being sent to the parent, right, are being filtered out by this window. So this window is not telling the whole story to its parent, which is what you want. And so there's a hierarchy, and and within that hierarchy there are parents and children, and the children inform the parent certain things, and hide some of the detail about what's going on from the parent, which then may or may do something on the basis of what its children are telling it. So that's the messaging part in a nutshell. This message loop is something that we don't have to write down when we use the DialogBox function, which we're going to use. All this part's hidden from us. In fact, it's completely gone. The DialogBox function will do all that for us. That's the function we're going to use, which I'll probably have to get to in the next video. Well, I can get to part of it. Looking at the help for this, that works. There are 4 parameters required are an H instance. Now that's the, as I said before, that's the the address in memory where to find the resource template, and that's what the second parameter is, and that corresponds to our little dialog box. This thing, now this thing has an identifier number, and that number happens to be up in here. Okay, so to pass it the correct template, first we need that number, and we got to turn it from an integer into a string. Well, it tells you how. You just take this, use this macro, and inside here put the identifier of the resource that you want to, in this case, to be made into a dialog, and the next thing, a handle to window for the parent, which we don't know. We can put null. Null is fine. And then the last bit, a dialog proc. Now this is how the messaging works. Dialog proc. Well, I'll just copy down the declaration. That. Oops. And again, we're back into historical things that don't, some of which don't make any sense and shouldn't. Why is this called W param? Why is this called L param? The reasons are historical. Again, back in the 16-day Windows, 16-bit Windows days, W here stood for word, 16 bits. Okay, the messages had the message thing itself. Let me find that. Here is a type of structure. Okay, now that the details of that structure have been hidden slightly from us, and all we're getting is 2 parameters and a message number, a message identifier. In the old days, this was a word. This no longer means a word. It's a an int pointer, so it's a 32-bit value. But and here is L param. In the 16-bit world, L stood for long, like a long pointer, 32 bits. Longs are 32 bits, and typically these types of parameters were pointer values, and these were numeric values, and that tradition has been maintained. Now this is okay to pass into our dialog box. As it is, this is now going to work, even though we get all these warnings. I can get rid of the warnings for now, since we don't know how to use these yet. Now, must return a value that's true. Again, now callback here is just standard call. Okay? The reason they have 2 words meaning the same thing is to give you a hint as to what the purpose of this thing is. This thing's purpose is to be called back on, and the reason something would call back on it is to send it a message. That's the message. The return value for a dialog proc is simply, oh dear, Is this dialog box? Yes. Basically, it returns true or false. Okay. And typically means sometimes, almost all the time, we should return true if we process the message, and we don't know how to process anything yet. False if not. So what we can do is just return false, and that's capital false, not the little false. And this just has the value 0. Because we're not processing any messages. Now if I run this, our dialog box should show up. And there it is. See? I can type into it. And if I look at this with the spy program, bring this up here and search for it. Here's our message box. Now you'll notice this again is a window, okay, and its caption is, here's the caption. Its class is a special class. This actually gives you the atom number, dialog. I went searching for some way to convert this number into this word, and I don't believe there is any way. That's just a known value. It's always been true, and it will always remain true. Okay, in hex that's 8002. Okay. There are 3 sub-windows in our window, for our window. There's this window, okay, which is of class button, right? And its caption is okay. You see how all these things are the same? Every window has a caption. It has styles, and the styles have to do with its class. And its class has usually a name or an identifier. And this is a global class, already existing class, and that class name is button. Process is the process it belongs to. Similarly for this cancel, okay, here's its caption, etc., etc. And now this one is a window of type edit class, another global class with its special styles. And I think we changed some of the styles, right? Some of the defaults. Its caption happens to be that text I typed in, and what it's not being displayed in this display here is the fact that there are carriage returns and so on in here. But that is part of the caption. But because it can't display those here, it just clipped them out for us. So for instance, if we could find the handle to that window and somehow found a way to extract its caption, then we could retrieve the text that we typed in here. And that's what we'll do at some point. Alright, so now currently it doesn't do anything because we're not handling any of the messages that come to it. And next time I'll go through some of the messages that come in and how to handle them and how to get the data from here, inside here, back to our program. Alright, I hope this is okay. We'll try it. That should be the next one fairly shortly.